This one is problem 1.39. It says a block of weight W rests on an inclined plane which makes an angle theta here, and a force P that is parallel to your x-axis is applied to the block gradually and increases. At a value of 0.4 W, the block begins to slide. Okay, what is the coefficient of friction between the block and the inclined plane? So basically we have to find out the value of F. Now in this problem, it's a simple problem on friction, but the direction of friction is a concept that we need to understand in this problem. Okay, so what we'll do is we will try to take out this block and then analyze all the forces on the block. Because it's an inclined plane problem, it is better for us to have a coordinate system that is parallel to your plane here. So this one becomes your y-axis and this one becomes your z-axis now. Okay, so rather than choosing these and these axes, I am picking y and z here. Your x remains as it is. Now when we start writing your forces, there is this force P. So force P, because it's pointing in the negative x direction, it can be written as minus P I cap. That is one force. Your weight is going to be pointing downwards. So if I draw the weight on the block going downwards here, this angle is theta, right? So if I take the components of this force, this angle is going to be 90 minus theta. So your W sine theta will be pointing in this direction, so I write it as j cap, and minus W cos theta will point in the direction that is opposite to k cap. That's why negative sign. Now in addition to these forces, we are going to have a normal reaction, and normal reaction will always point in the normal direction here. So let's take that as maybe the value of normal reaction is n, and it is going to point in the k cap direction. After all these forces, now we talk about the friction force. Okay, now friction force, whatever happens, will always be within this plane, right? Because it needs to be parallel to the plane, or your plane is going to be defined by this axis right here and the perpendicular one. So only two components that you are going to expect here is the friction will have an I component there and your friction will have one J component there. So these are all the forces on the system, so we can put this equals to 0. Now since this is a vector summation, we can compare all the I component, J component and K component in this case. If I look at your I component, it looks like it gives us the Fx value has to be equals to P, and since value of P when it is moving is 0.4 W, so your X component of friction is nothing but 0.4 W. From the Y equation, we can see that your Fy, which is this, is going to balance this one right here, which is going to give you minus W sine theta. And looking at this triangle, your sine theta is going to be 0.6, so this is minus 0.6 W. The last one, which is your k cap component, that gives you a value of normal reaction, which is W cos theta, and from the triangle this value is 0.8 W. Now if you notice the sign of Fx and Fy here, Fx is in positive direction and Fy is in negative direction. So positive x means your x is pointing this way, so your Fx is right here, which is opposing the tendency of motion in the x direction. Similarly, your Fy is negative, your y direction is here, so your Fy is going to be pointing upwards right here, okay, which is also again opposing the motion. So from that sense, your directions are coming properly. Now to calculate the friction coefficient, we can use the idea that the friction force is proportional to the normal reaction force. Okay, so in this case, if I take the magnitude of this friction force and equate it with the coefficient of friction times magnitude of my normal force here, so your coefficient of friction F can be written as the magnitude of friction force divided by magnitude of normal reaction. So if I put these values back in here, your F can be written as, so your friction force is defined by two components here, so the magnitude is going to be 0.4 square plus 0.6 square W, and in the denominator we have the normal reaction, which is 0.8 W, and if I simplify this, I get the value of F as 0.9.